1. Here's the overall description. You need one? Okay. It's okay. Now I'm all out. Okay, so the overall description, you've already done parts A and B here, okay? Most of you have already done this because we did it in class last week. So I want you're going to devise a vote. At least 20 people have to choose among 4 options and conduct the vote. So most of you have already done that. If you haven't done that, you want to get that done as soon as possible because you don't want to put this off to the night before and realize you have to collect a bunch of data. Okay, so do that as soon as you can. Part C is to create a preference schedule summarizing the votes. So we have learned about what a preference schedule is last class. That's where you summarize all the identical ballots, right? So you put all the people who voted, say, B, C, D, A. That's one column, and you put like an 8 at the top. There were 8 ballots that looked like that. Okay. So look in your text, look in the notes for how to create a preference schedule. We talked about it in previous classes. All right, once you have that, then you figure out the winner of the vote according to each of the 4 voting methods that we have already discussed. We learned plurality, board account, plurality with elimination, and pairwise comparisons. And you're going to do it on the attached sheets. If you need more space, you can do it on other paper and attach it. Make sure you clearly label any other papers. And then part E is to answer questions on the last page of this packet about fairness criteria, which is the topic of today's class. Then the last couple of things you're going to do is write a paragraph of at least 4 sentences, summarizing what you find most interesting about your results. You're going to hand in all your ballots, right? So you're going to group all identical ballots together and staple them, right? So you're going to, all the voters who voted B, C, A, D, take all the ballots that look like that and staple them together. Okay? And then you're going to have it hand in like all your little packets of votes, of ballots. And then you're going to turn in your ballots and the project at the end. Now, if you collected your ballots in something that looks like this, right? You just had people fill it out in one page like that, that's fine. You can just hand this in, okay? If you don't have actual ballots. All right, questions about what the project is or how to do it? Okay, good. So let's look at today's class so that you will have all the info you need to do the questions at the end. Okay, so the material in this section can be tough. Yes, question? Yeah. Mm-hmm. Did the question like explained, like here's another method, do this? Okay, that's okay. Last class we learned about plurality with elimination, and I had in parentheses, I didn't, and I pointed it out, but I didn't, harp on it. Plurality with elimination, also known as IRV, instant runoff voting. Okay, so that's the method where you force a majority. You eliminate candidates till someone has a majority. Yep. Okay. So the material today can be a little bit tough. Be patient with yourself as we struggle with some new vocabulary and ideas. Okay. We're going to start by making sure we have a clear understanding of if-then statements. Okay, and when an if-then statement is true and when it is false. Okay. All right. So suppose I want to stick to an exercise regimen and I plan to follow this rule. If the weather's okay, then I will go for a run in the morning. This is my rule. If the weather's okay, then I will go for a run. Okay. So either the weather's okay or it's not, right? And so either I run or I don't. So I'm going to look at each of these 4 possibilities and decide whether or not I broke my rule. So I set this rule up for myself. I have to decide whether or not I broke it. So first option, the weather is okay, and I go for a run. Did I break my rule? No. Okay, so this is fine, right? B, the weather is okay outside, and I don't go for a run. Did I break the rule? Yes, I broke the rule. Okay, so this one's not okay, right? Rule broken. If the weather is not okay, and I go for a run, did I break the rule? My rule is that if the weather's okay, I have to go for a run. I didn't say what I would do if the weather was not okay. I committed to running when the weather's okay, right? If the weather's not okay and I still go for a run, is my trainer going to yell at me? No, that's fine, right? And if the weather's not okay and I don't go for a run, did I break the rule? No, that's allowed, right? I only have to run when the weather's okay. So there's only one way to break the rule. If the rule is, if the weather's okay, then I will go for a run. The only way to break the rule is if the weather's okay and I don't run. Does that make sense? Okay, so there's only one way to break an if-then statement in general. It's when you satisfy the if part and don't satisfy the then part. Okay, so in general, if the weather's okay, satisfied, right? But I don't go for a run, unsatisfied. So the only way to break an if-then statement is if the first part is true and the second part is false. Okay. The only way an if-then statement is false is if the if part is true and the then part is false, right? The weather's okay, but I didn't run. Okay. All right, so now we're going to get back to our analysis of elections. You'll see how it ties in. For a completed election to be considered fair, it has to meet a few certain criteria that many political scientists and mathematicians and the general population agree are important criteria to consider an election fair. The first and most basic expectation is called the majority criterion. Okay? It says that if a candidate gets a majority of the votes, they should win the election. So if someone has a majority of the votes, then they should win the election, right? We have an if-then statement, just like my rule with running. So if a candidate has a majority, if majority, then they should be the winner, right? So let's analyze the majority criterion by considering this preference schedule. Okay. Does any candidate have a majority of the first place votes? Okay, how many people voted? 7. So what would a majority be? 4, right? So 7 voters. So more than half. So half is 3.5, but a majority is more than half. So it takes 4 for a majority. Does any candidate have 4 or more first place votes? Yes. Okay, who? Yes, A has a majority. Okay, so my majority criterion says that A should be the winner. In any fair election, A should win. Does that make sense? If someone has a majority, then they should be the winner. Okay, so let's calculate the winner using board account method. Okay, so this is a good time for you to try to remember how to do board account. And I want you to take 2 or 3 or 5 minutes in your groups and figure out the winner. All right, so most people, if you're not done or are on the right track, seem to know what you're doing. Okay, so let's write this out. For candidate A, we'll calculate points. Every ballot where a candidate is put in first place, they get 4 points for that. So candidate A is in 4 people put candidate A in first place, right? These 4 people all have candidate A in first place. So 4 ballots, each one gets 4 points for candidate A. And then 2 people have candidate A in last place, and last place votes are worth 1 point. And then 1 person has candidate A in last place, and last place votes are worth 1 point. So you add those up, you get 16, 18, 19. Stephanie, you have a... 3. Yeah, I just did them separately. I did these 2, so there's 2 and 1. So that's the 2 and the 1. You can combine them into one single term if you want. Okay, and then candidate B, let's see, the first 4 people, that first column has candidate B in 3rd place. How many points do you get for a 3rd place vote? 2. So we have 4 times 2 plus 2 times, that second column has B in 2nd place, so that's worth 3 points. And the last column has B in 3rd, which is worth 2 points. So that is 8 plus 6 is 14 plus 2 is 16. Okay, now somebody who's already calculated it, what do you get for C? 24, and for D? We have some 11s and some 13s and a 12. 11? I think it's 11. It should be 4 plus 4 plus 3. That's 11. Okay, so C is the winner, right? They have the most points using board account. Okay, so A had a majority of the first place votes. So the if part is true, right? If someone has a majority, right? Satisfied, A has the majority, okay? But A didn't win, right? A lost the election. So that's the then part of the majority criterion. It says that if A has a majority, then A should win. So A has a majority, but A did not win, so we broke the rule, right? But instead of calling it a rule and saying we broke it, we call it a fairness criterion and we say we violated it. So we say the board account method in this election violates the majority criterion because we had a candidate who had a majority of the votes and did not win. Does that make sense? Okay. So below are the 4 possibilities for the truthiness of the if and the then statements in the majority criterion. So one of the 4 statements should feel unfair. Okay, circle the statement that would indicate a violation of the majority criterion. Okay. So discuss in your groups which one of these is the unfair scenario. All right, so it appears that most people have agreed that B is the unfair outcome, where a candidate wins a majority of the votes but does not win the election. That feels unfair, right? Someone won a majority but didn't win the election, right? If this happened where you had a vote among children, you know, you'd have a little temper tantrum. But I had a majority, right? Might have that anyway, right? People can get very confused with the last 2, right? Where somebody who wins, even though they didn't have a majority, that doesn't violate the majority criterion. If no one has a majority, the majority criterion says nothing about who should be the winner, right? It just says that if someone has a majority, they should be the winner. But if no one has a majority, the majority criterion says nothing. Okay, does this make sense? All right. So that is the first and most basic fairness criterion. It's called the majority criterion, but there are others. There are other ways that we measure the fairness of an election. And the next one is called the Condorcet criterion. Condorcet is a French mathematician who came up with this fairness criterion. Okay, so it says if candidate X is preferred by the voters over each of the other candidates in a head-to-head comparison, then candidate X should be the winner. So this is like the pairwise comparisons method, and it says that if there's a candidate who wins all of their head-to-head matchups, right, an undefeated candidate, then they should win the election. So let's consider an example here. Here's Tasmania State University's marching band. They have been invited to perform at 5 different bowl games: the Rose Bowl, the Hula Bowl, the Fiesta Bowl, the Orange Bowl, and the Sugar Bowl. And there are 100 members of the band, and these are the results of their vote about where they should choose to play. All right, so according to the plurality method, where should they go? The Rose Bowl, right? 49 votes has the most first place votes. Okay. Now we want to know, is there a candidate who beats every other candidate in a head-to-head comparison? This is harder to figure out just by looking at the preference schedule. We actually have to do all the head-to-head comparisons, or we could try to guess, is there a candidate who's going to win all their head-to-head comparisons? So let's think about, so Rose Bowl clearly wins with plurality, but everyone but these 49 has Rose Bowl in last place, right? So Rose Bowl may not be the best option for this band to choose. What would be a good, compromise candidate? Emma? H, Hula Bowl. 48 people have it in first place, right? And everyone else has it in second. So that might be a good compromise candidate. Let's see if Hula is a Condorcet candidate. Okay, so that's going to be my guess and if it's not, we just have to check all the head-to-head matchups. So I'm going to match Hula against every other bowl game head-to-head and see who wins. Okay, so I'm going to do Hula against Rose Bowl, Hula against Sugar Bowl, Hula Fiesta, and Hula Orange. So I'm going to check these 4 head-to-head matchups. Now every voter has a preference. Hula over Rose, right? So let's take a look. These 49 people, if they have to choose, who would they choose, Hula or Rose? Rose. Okay, so 49 for Rose Bowl. Now everybody else, since Rose Bowl is in last place for everybody else, would choose Hula, right? So it's 49 to 51, Hula versus Rose. 51 for Hula, 49 for Rose Bowl. Right? So Hula wins that matchup. Okay, let's do Hula versus Sugar Bowl. Okay, so these 49 people, if they had to choose, would it be Hula or Sugar? Hula. How about everybody else? Hula or Sugar? Hula. Everyone has Hula Bowl ranked above Sugar Bowl. This is 100 to 0. Hula, Sugar. Okay, so Hula Fiesta Bowl. Again, oh no, it's not 100 to 0. What is it? 97 to 3. Both of the first 2 columns have Hula ranked above Fiesta. Hula above Fiesta. The last column of 3 people has Fiesta above Hula. Okay, so it's going to be 97 to 3, Hula winning. Now Hula versus Orange Bowl, 100 to 0. Everyone has Hula ranked above Orange, so 100 to 0, Hula wins again. Okay. So Hula, when you match it against anybody else, head-to-head, Hula wins every matchup. Hula will always win. So that's what the Condorcet criterion says. It says that if there is a candidate preferred head-to-head over anyone else, then they should be the winner of the election. Okay. So Hula, we say, is a Condorcet candidate. You could also call them an undefeated candidate. In their head-to-head matchups, they're undefeated. Okay. But Rose Bowl won, right? If we use plurality, Rose Bowl wins, even though there's a Condorcet candidate, Hula Bowl. Okay. So in this election, we say the plurality method violates, because we broke the rule, the Condorcet criterion. Because we had a Condorcet candidate, we had a candidate who is undefeated but did not win, right? Because the Condorcet criterion says if you have an undefeated candidate, then they should win. Okay. For 11, number 11 here, we have 4 possibilities for the truthiness of the if-then statements regarding the Condorcet criterion. One of them should feel unfair. Decide which one you think it is in your groups. All right, so only one of these feels unfair. Most people have circled B. If candidate X can beat every other candidate in a head-to-head comparison, and candidate X does not win, that feels unfair. Candidate X will be really upset about that. That's the only case where we have unfairness, right? If no candidate is undefeated, if no candidate can beat everyone else head-to-head, there's no unfairness. Doesn't matter who wins. We haven't violated the criterion. Yeah. Yes, you always make all the pairwise matchups and figure out if there's someone who's undefeated. Yeah. It looks like using the plurality method. You just have to do all the matchups and find out if there's an undefeated candidate. All right, so we have a third fairness criteria here called monotonicity. So monotone means what? Constant, right? Or the same. So monotonicity has to do with things remaining the same. All right, so if candidate X is the winner of an election, and we have to hold a re-election for whatever reason. So we had one election, candidate X won. And we have to hold a re-election because whatever, there were irregularities in the ballot or any reason. There are many reasons why you might hold a re-election. If in the re-election the only changes in the ballots are changes involving some voters ranking X higher on their ballot, right? So they're only good changes for candidate X, where some people have moved candidate X up, right? And they don't change the order of any of the other candidates, then candidate X should still be the winner, right? Monotonicity means the winner should remain unchanged. The winner should be constant if the only changes are good changes for candidate X. So here's a little example where you can see a violation of this criterion. So we have 3 cities, Athens, Barcelona, and Calgary, competing to host the Summer Olympic Games. The final choice is made by the International Olympic Committee, and they choose by using plurality with elimination. And this is true. This is really how the International Olympic Committee votes. They use plurality with elimination. So 2 days before the actual official election is to be held, they have an unofficial poll just to kind of see how things stand. And these are the results in this preference schedule. So we want to use plurality with elimination to see who's expected to win. Do you guys remember how to do plurality with elimination? You start by doing plurality, right? A has how many first place votes? 11. And B has 8 and C has 10. Does any candidate have a majority of the first place votes? How many would they need for a majority? So let's see, we have 19, 29. Half of 29 is 14 and a half. So they would need 15 for a majority. So since no one has a majority, what do? Eliminate the lowest. So we're going to eliminate B. Yeah, how do we decide who to give B's votes to? Who is ranked next in the preference schedule? So these 8 people who had B in first place, if B is gone, they would choose C. So we're going to give those 8 votes to C, and we have A 11, C 18. Okay, so does anybody have a majority? Yes, C has 18. C is the winner. Okay, so Calgary, based on the poll 2 days ahead of time, before the official election, we're expecting Calgary is going to win. All right, so the results of the poll are supposed to be secret, but the results leak out. And everybody loves a winner, right? So the delegates in the fourth column, these people over here, these 4 people who have ACB, they decide, okay, we're going to jump on the Calgary bandwagon, and we're going to switch Calgary and Athens. We're going to put Calgary into first place because we want to be able to say we picked the winner, right? So we're going to make a new preference schedule where we put Calgary in first place instead of Athens. And that means that these 4 people are going to vote the same as these 10 people, right? So we're going to have 14 ballots that go CAB. So it's going to go 7, 8, 14 now. So we have 7, 8, 14. And these 14 are CAB. And then the other 2 were ABC and BCA. Okay. Okay, so here's my new preference schedule where I have taken those last 4 people and had them vote CAB instead of ACB. All right, now in your groups, I want you to figure out the winner using plurality with elimination now that those 4 people have made positive changes for Calgary. And that's the only change is that was a good change for Calgary, already the winner. Who wins now? B, right? We need 15 votes for a majority, right? So we count up the first place votes. A has 7, B has 8, and C has 14. No one has a majority. Who gets eliminated? A. A gets eliminated. And we decide who gets A's votes by looking at the preference schedule. We say these 7 people who had A in first place, if A is not an option, we know they'd go for B because they have B ranked next. So we're going to give those 7 votes to B. And now we have B with 15 and C with 14. And B wins the real election, the official election. So to summarize, Calgary was the winner of the unofficial vote. Then a revote happened, and everyone kept their votes exactly the same except some voters who moved Calgary higher. And surprisingly, Calgary doesn't win anymore, right? Calgary was the winner. The only changes were positive changes for Calgary, and now they lose. This is a violation of the monotonicity criterion. So plurality with elimination, that's the method we were using. So the plurality with elimination method violates the monotonicity criterion. In this election, it doesn't always violate it. It's just possible to rig an election where that happens. So in this election, plurality with elimination violates monotonicity. Any questions so far? All right, so we have one more fairness criterion, one more way that we measure the fairness of an election. This one is called independence of irrelevant alternatives, known as IIA, also known as the dropout criterion. Okay, so it says if candidate X is the winner of an election, so we have a winner, and in a recount, for whatever reason we have to have a recount, right? One of the non-winning candidates withdraws or is disqualified. Candidate X should still be the winner, right? So we're going to elect a mayor in Greenfield. There's a very small turnout at the polls, and this is our preference schedule. There were 7 voters, right? Who's the winner using the plurality method? A. That's where we just count first place votes, and the winner is the one with the most. A. After the votes were all cast, but before the votes had been counted, right? The people doing the counts are very slow. a scandal involving candidate B comes to light. Okay? And candidate B decides to immediately withdraw from the race. The votes have already been cast. The election is officially complete, but it wouldn't be fair to the candidates or the voters to ask them to re-vote. Okay? So we're going to cross B off of all the ballots. Just get rid of B, because we know how people would have voted even if B wasn't in the race, because we know their relative preferences. So we can just cross B out here, cross B off every ballot. And now my new preference schedule would look like this. First, second, third. I would have A, C, D would be that first column. Now the B is gone. And then my other two columns are both CDA. CDA. So I just have CDA, 4 of those and 3 of the ACDs. Now that B is gone. Okay. Now who wins using plurality? C. Okay, so that doesn't make any sense at all, right? A was the winner. The residents of Greenfield said, we like candidate A, we want candidate A to be our mayor. And then B drops out of the race. Completely irrelevant, right? Doesn't matter. A is our guy or our lady, right? But then when we recalculate the election, C wins now. Just seems like quirky. It's weird. Okay. So in this election, we have violated IIA, or the dropout criterion. So in this election, the plurality method, because that's the method we were using, just counting first place votes, the plurality method violates IIA, also known as dropout criterion. An irrelevant candidate, that's why it's called IIA, independence of irrelevant alternatives. So an irrelevant candidate dropped out and it changed the winner of the election. Is that what? Yeah, that can really happen. Yeah. Well, you don't actually, you would have to have access to all of the data to know whether or not your dropout would make a difference. So it's hard to manipulate unless you have all the data. Okay, so here are all 4 of the fairness criteria. They are also listed on page 9 of the packet, like near the beginning. So here's a summary for how to determine that there is a violation. So for majority, in order for there to be a violation, a candidate must have a majority and not win. That's the only way to violate it. For Condorcet, you must have an undefeated candidate, an undefeated and head-to-head matchup candidate who doesn't win. For monotonicity, you have to have a candidate who wins in one election and doesn't win in a re-election, even though the only changes for that candidate were positive. And for IIA, you have to have a candidate who wins, but then doesn't win when the votes are recounted after someone drops out. So that's just a little summary of how to identify a violation of a fairness criteria. All right, so this is very kind of like tricky and subtle, identifying these violations. So I want you to have, a good amount of time to work in class on this voting activity number 3. We might even have to spend a few minutes on it at the start of next class, okay? Because it's kind of long. So I want you to work in your groups. The answer key follows the questions. So you just turn the page, you'll find the answers. And let me know if you have any questions. I'll be coming around to help groups as needed.